So yeah, thanks for joining. Show of hands, is this their first time at the Remix Austin meetup? Oh my gosh, that's like a good amount. Yeah, thanks y'all for coming. Really appreciate it. So if you don't know, Remix is a full stack framework built on top of React. And you can build really cool full stack stuff. Tonight we have an awesome speaker, Annie from Sly.io, going to be talking about serverless, sort of JavaScript with rethinking serverless and JavaScript. It's a good thing that I have this nice little sign up here. And yeah, Fly is super cool. It's actually the Remix Austin website is built on Fly. Also, the Remix website is built on Fly. So very beloved in the Remix community. If you haven't checked it out, it's pretty cool. I'm not going to spoil all of it. Annie will be able to do a much better job explaining what it is than I will. But yeah, I don't have my slides because we had some technical issues earlier. So I'm going to try and remember usual things I say. First thing I'll say is if you ever want to give a talk at this conference, Meetup, you should come talk to me. Or we have an online forum as well. If you'd prefer to write your thoughts instead of directly talk to me, then go for it. But always looking for speakers. And also I love, just hearing the community share things that they're excited about. It can be as simple as like, hey, I learned how to do this thing in Remix that you think is very common or not that special, but it may be the first time someone else saw it. Or maybe it's, hey, I built this thing in Remix and I think it's really cool. I built a cool game or my personal website or a blog, or I guess please build something besides a blog. We've seen enough of those, but besides that, you can build something else in Remix. Or maybe it's a concept like, hey, have you ever rethought serverless in JavaScript? That would be a great talk. Not in the future, we're going to do it tonight, but something along those lines. Beyond that, what else was I going to say? Not a lot of things. We usually have a sign in, but I'm not going to show that because I can't. But hopefully you all signed in as you came in. We do this meetup once a month. It's usually the first Wednesday of every month. So be on the lookouts for the next one. I'll try to get it scheduled as soon as I have confirmation that we can be here. But yeah, thanks so much for coming. Thank you, Grant, who's our HEB representative, for opening the doors and making sure that we're here and everything. We also record all these talks online. So if you ever want to watch old talks from the past, they're on our YouTube. Which is on our website, which is remixaustin.com. Again, I would show you all these things, but it's pretty easy to find. Remix is kind of hard SEO, but if you do Remix Austin, you can see actually I don't know, good luck, I guess is all I'm trying to say. SEO is kind of hard on that one, but you found this meetup, so I have confidence you can find our YouTube channel as well. But I think that's all I have, Annie, if you're ready. Cool. All right, give it up for Annie.
All right. How's everyone doing tonight? Woo! So, all right, very enthusiastic. So yeah, my name is Annie Sexton. I actually met Brooks at Epic WebConf a couple weeks ago, and when he learned that I would be in town for a conference, he was like, "Oh, you should stop by the Remix meetup," and I was like, "Hell yes!" So, and I'm really excited to be here because we are going to be, as the title says, we're going to be rethinking serverless functions. Serverless is a great tool, but there are caveats to it that I want to introduce a new solution to that I did not come up with, but I think it's pretty interesting. But before we get into any of that, I should probably tell you guys who the hell I am. Well, first and foremost, I'm an Austinite, born and raised. Do we have any Austinites? Yeah, we got two. Yeah, great. True. Yeah, it's good to be home. I've been a full stack developer for, I don't know, God knows how many years now. I used to work at Render and then Heroku before that. And now I work at Fly.io. Are we noticing a trend here? So my current role is a JavaScript specialist, which what the hell does that mean? Nobody knows. No, all it means is that I'm an advocate for the JavaScript community to make sure that they have the best experience deploying apps on Fly. Now, for anyone unfamiliar, Fly.io is, a lot of people will call it a platform as a service. We are really more like infrastructure as a service that's just really easy to use. And we make it really easy to deploy apps on fast booting VMs all over the globe. You might even think of it as like edge routing, but including your database, your object storage, all of the things that can be close to your users. So it's really cool and it's really easy to scale. Anyways, that's my marketing spiel. Moving on. And we're not an abstraction layer on top of another cloud provider. We are bare metal. It keeps the cost down and it's really easy to use. So why do we use serverless functions? This is a real question. Why do people reach for functions as a service? AWS Lambda. Why do people reach for that?
Scalability.
Scalability, right. Affordable,
limit the request? I mean, only cost you when the user.
Right. You're only paying for that compute time. So it keeps the cost down. And the scalability is huge, right? You can like infinitely scale any task so long as you have the budget for it, right? But when you get into more complex tasks, serverless does not always mean simpler. And I'm going to give you an example of this. So, and this is where we're going to just like pray that the audio works. So I'm going to give you guys an example. I'm going to show you a 1-minute video of my buddy Chris here demoing an app that would not be so simple to just throw out on a Lambda. And it's an app that generates thumbnails as a video is being streamed in. So let's cross our fingers. Here we go.
So we have this application over here. It's a thumbnail generator. You give it an MP4, it transcodes the video with MPEG and generates thumbnails. But one of the cool things about it is it does this as the file is being uploaded. So it's running locally here, just a bit of Elixir and Phoenix Live View. So if I select this file on the server, it's going to say as the chunks are being uploaded on the client. So this is only 20% done. We're sending each chunk to MPEG running on the server. It's sending standard out back, and the live view is picking out the PNGs as they're being generated. So this doesn't have to hit disk. This is all data in, data out. But this is a very expensive operation, right? So if we get these nice pictures of this puppy here, and I kick off another operation, we can see just how expensive this kind of thing is. So if we kick this off again, and I go back to our server, and we actually connect to that server and pop open HTOP, we can see that we're actually, the server is running really hot right now. So 24%, 30% CPU just for one user doing one upload, right? So this is a taxing process. It's in the critical path of our app, which is our web server. So, how would we scale this, right? And traditionally we'd reach for, Cloudflare workers, AWS Lambda, we pay someone the privilege to handle this kind of like CPU intensive elastic scale.
Okay. Did that make sense? Yeah. So it's on the fly. Nothing is getting written to disk. Very CPU intensive. So what would that look like if we were to do that using serverless architecture? Well, you'd have like custom encoders and decoders on both sides to send the video over, to stream it over. And then you generate the thumbnail and send it over HTTP back to the client. Easy enough, right? But what if the user upload is going to take longer than 15 minutes? Well, then you're going to run into a hard timeout. And so then we got to chop our video into chunks in order to avoid the timeout, which means more Lambdas. And so now we're having to orchestrate Lambdas and integrate additional services such as SQS and S3. And it starts to get complex. And eventually you're going to need like all of this just to get this working. He already had it working on his application as is. It's just that we don't want it on one single server, right? And this is where we introduce this new concept that's the alternative to serverless. And it's called Flame. So Flame is an acronym. Buckle up. This is Fleeting Lambda Application for Modular Execution, obviously. And the elevator pitch is this. It's, what if you could auto-scale any task simply by wrapping existing code in a function that then runs that code on a temporary copy of your application, right? It kind of feels like background jobs a little bit, but it's not quite. So if you think about serverless, you have these isolated functions. This would not be isolated. It have full access to whatever you have in your code. And it sounds like it might be intensive, like having a whole machine ready, but you'll find it's actually not. Okay, so, well, first of all, to give credit where credit is due, that guy you just saw, his name is Chris McCord. He's the creator of the Phoenix framework. He's one of my coworkers. And the Phoenix framework is an Elixir app, an Elixir framework. And the thing about Flame is it was initially made for Elixir. And Elixir is a special language that has kind of this like unique clustering ability that I'm not going to pretend to understand fully, but it makes it very, very well suited to this Flame pattern. But it got people thinking, well, could this work in another language like JavaScript? And it turns out it works. And it would look something like this. This is as simple as it would be. You have some random task that you want to be able to scale, and then you just pass it to this Flame function. Magical. I promise it's not witchcraft. So I want to explain what's happening behind the scenes. So everything I'm explaining is what's happening you'd basically have a single Flame library that would allow you to do stuff like this. One file, okay? And so I'm gonna explain how it works behind the hood. Under the hood, you know what I mean? So we have a web app. We're gonna start with a very vanilla, just a simple Node app. No framework, no nothing. And we're gonna do some complicated math stuff. This is the task we wanna scale. We're getting some sum from this run math function. Now we're importing it from app/run math. What does that look like? Well, here, this is sort of similar to the code snippet I just showed before. You have the function definition, and then you're passing it to this Flame function. Now it's important to note this is the default export of this file. That's important, okay? Now that Flame function comes from your library. This is the Flame library. This is where it lives. And this is the core of how this works. So this Flame function, it's important to know, it runs twice. It's recursive, but it only ever runs twice because it's got a different job each time. The first time Flame is called, it first says, hey, do we have any runner machines? And by runner machines, I'm just talking about copies of your application that we're going to run the task on. We're just calling them runner machines. Now machines, I'm saying machines with a capital M, because in this example, we're going to pretend like you're deploying on fly.io. And on Fly, you use machines. And those are literally just virtual machines, like very fast booting virtual machines. That's all it is. And you run your app in a container. So the first time that Flame runs, it says, hey, do we have any runners? If not, we make one. Boop. If we do have one, then we move on to the next step, which is that we send that runner post request. Now, our runner app is actually running a very simple, it's got the same application code, but it's running a very, very simple HTTP server. And it's just listening for two requests. One is that, just a simple health check, just to say like, hey, do we have a runner? Are you alive? And then the other one is this post request. A post request which accepts two arguments. It's got the path to our function, the path to here, which in our case is app/run math, and then any arguments that we're going to need to run that function. Okay, so we send that post request to our runner. Then we dynamically import that in our runner machine. This is when we're processing the post request. And have y'all used dynamic imports before? Yeah, so like not at the top of the file. Anyways, so we're going to save this as like const module equals, await import. And so we're going to then use that default export and then run it as a function, passing some arguments to it. And so this is the second time that Flame will get called because we're importing it again. But this time around, it knows that it's running on the runner machine. So it doesn't need to bother with checking for machines or anything. It's done that already. Now, we actually run our task. Okay? So we run the task, and then we just send that request, the result of that, back to the main app. So first, do we have any runners? Okay, spin one up. Now do the task, send it back. That's how it works. How much does that make sense? Good. Okay, I'm seeing that. It's cool. So in the end, okay, so what I'll describe, a little bit complex, but in the end, this is all it would look like in your code. You just have whatever task you want to scale, pass it to a Flame call. Now, it's worth noting that this is not without limitations. So I want to call these out before we dive into like the remix stuff. So first of all, it's important to note that when you use a Flame call, it does need to be somewhere where it can be a default export in a file. It does need to live in its own file. Your actual function, this can live anywhere you want. It's kind of nice to have them in the same file, but it doesn't matter. So, other thing, you don't want to be mixing common JS with ES modules. You're going to run into errors by trying to import things that are mismatched. And then at least in the example I just talked about, and this is a biggie, it's not really going to work with TypeScript very well. Yeah. If you're running Bun or if you're using Dino, I don't know what you guys say. Dino, cool. I mean, that'll be fine, but in most cases, you're probably running Node, and that's not going to work unless you're using something like Remix. So, here we go. Let's, so I'm going to show you, I will show you a sample Remix app, but I first want to show you some code from a simple Node app. Basically, the workflow I just talked about. I want to show you a simple Node app. And I cannot take full credit for this. In fact, I got to get him. Let's go to the Chrome. Okay, cool. Oh my gosh, I'm going to have to operate this from afar. Let's go here. All right, great. Thank you. It's going to be very awkward. Okay, so Lubian is my coworker who, he was really the one who came up with this workflow for JavaScript. I cannot take credit for that. I can take credit for the drawing though. But I want to take a look at the Flame library in this very simple Node app. So it's just in this file here. And there's a bunch of stuff in here. Don't worry about it. I'm going to scroll down to, oh, thank you. Yes. Let me, how's that? Is that good? Okay. So if we scroll down here to this function that says spawn another machine, surprise, surprise, this creates another machine. And right here, we've got all of this configuration that we send to okay, so this is using the Fly Machines API. This particular library does. So what this does is it spins up new copies of your app using whatever image you want, overriding any environment variables, all sorts of things like that. I will say Flame is not Fly specific. You could do this on any platform that had some way of spinning up new instances of your app. It would work. But here we're just saying, hey, use this image, override these environment variables, and then this right here. I don't know how familiar y'all are with Docker. So entry point and command, basically the same thing. This is what you tell the container, hey, this is what I want you to run to start the application. And in this case, rather than running our standard Node application, which would be like node index.js or whatever, we're actually running this script instead. Now, why are we doing that? Well, if we scroll up, boop, boop, somewhere, here we go. If is runner, this is how we know to start that simple web server. Remember, our runner app is running a web server. And if we're on the runner machine, we create a little request handler, and then we start our server, right? Now, this whole thing works as a simple web server because of these two lines. This is where the magic happens. You're getting the default import from your file, your run math file, whatever it is, and then you're running it as a function and passing in whatever arguments. That's how it works. However, that only works in this app because we're able to import it based on the absolute path to that file. That doesn't work in a Remix app in production because all of your files are going to be like bundle, build/server./index, right? That doesn't work. What's a girl to do? So let me find that thing. But then I got to change my notes. I need 5 hands. Okay. All right. So now we are going to take a look at my crappy Remix app. I need to preface this by saying I had not tried out Flame in a full-on framework until 2 days ago. So this is very brand new code, not tested, not production ready. Please don't copy and paste this into anything critical. Used and warned. So, but I want to show you how this is different. So I've got a simple Remix app here. And I want to show you the Flame library in this one. It's a little bit different, but not too much. So, and you can see I was able to use TypeScript. So I don't expect you to have memorized the whole Flame library. I can just tell you that it's basically the same. But if we look towards this spawn another machine function, you'll see that there's no overriding of that entry point, which means what's the process we're using here? Whatever we're using to start Remix, npm run start, or whatever, right? However, if that's the case, then how do we know how to handle that post request? Well, we got to create a route for it. So this does take a little bit of extra work. So in our routes, I have defined a simple flame route. You can call it whatever you want, but it would always, you can put this route wherever, but it would always look like this. And so ignore all the console logs. So we get our request, and then here's that same import statement, but it is a little bit, I'm so sorry, it's very hard to highlight from this angle. There. So it's a little bit different. We're not actually using the absolute paths when we're importing it. We're actually using the file name, and we're able to import a full-on TypeScript file, right? So that's cool. And I'll be honest, I don't love this. Y'all are probably much smarter than me and can probably figure out a whole other way of doing this. But this is sort of the workaround that I've come up with. And I'll say this. So, and I don't think I explained this before, but y'all are Remix people. We've got our loader here. There's no component because this doesn't need a component. Our loader is just that GET request that we'll use to say, hey, do we have a runner available? That's what we use. And then our action is going to be the post request that actually runs our function. And so if we look at, so the only task that I have is the same sort of like run math function here, right? Function, it's very complicated. We're adding 2 numbers. So here is, I'm passing this as an argument. Run math. I am manually typing in the name of this file. I don't love that. I want a different way of doing that. Y'all can help me think of a different way. It used to be that I would use import.meta.url. And that works if your files aren't all squished together. But in Remix, they are. And so if I were to do this in production and use the import.meta.url, I would get build/server/index.js. That's not what I want. So this is what I've come up with right now. There might be a way around it that still needs some massaging. But just to back up, I got to find my mouse again. Where are you? Come back to me. Okay. So that's how it would work. So just to step back, the way this would all work, the way you could implement Flame on Remix is it's still basically the same library, except for it's not starting its own server, same library, and then you just add a couple of routes. And those routes can basically be the same throughout any Remix app. Any Remix app. And that's how it would work. Now, let me get back to presenting mode. There we go. In the example that I just showed, it's not fully fleshed out. One thing is that it really needs some way of stopping the process after a while. Because otherwise you're just going to have like dozens of like endless runner machines. So that's something I haven't baked in yet. Needs exploring. But a cool thing about doing this on fly is that you can stop one of these runner processes and not destroy the machine. So you're not going to incur any cold starts, but then you might think, well, okay, but then I have all these like machines running around. Isn't that going to be costly? No, it's not, because we don't charge for stopped machines. So it's like you just have like a fleet of them available. And if you need more, you can spin up more, but it's really, really convenient. And then the other thing is you can easily make those runner apps not available to the public internet. So when you're connecting to that runner app, it's on a private network on fly. So it's very, very fast. Now, boop, I'm going to skip that one. All right, I'm going to skip straight to this. So I've just showed you how you can implement this pattern of Flame to find a different way to scale applications horizontally without having to do this like juggling with like SQ and all these multiple lambdas and stuff like that. You can all do it and you don't have to split up your application code. So it's a really, really interesting concept. I would encourage you guys to explore these sample apps. So this is, I will provide links somehow to you guys to the GitHub repos. This is the one that my friend Lubian wrote, the simple node app. And then I will have my Flame Remix example up on GitHub as well. If you want to learn more, this whole talk was kind of inspired by a blog post that I wrote. playing for JavaScript, and you can find it on the fly.io JavaScript journal blog post. So with that being said, I'm sure you guys are probably going to have some questions, but that's all. And thank you. Follow me on Twitter.
Is the reason that Lane has to be that file simply for remix routing, or is that for?
It's kind of a JavaScript specific thing, because you'll notice it was the same with, well, I don't know, actually, I don't think I showed it to you, but it was the same with the simple node app. It needs to be able to be, because the whole reason this works is because you're dynamically importing it, and it needs, you're dynamically importing it, and then you're just running whatever the default export is, and you're just trusting that that's like a function to be run. So it does need to be that, there may be a different way. This is what we've come up with. This is very sort of experimental. I don't know anyone running this in production. This is a very new concept, but it's really, really cool. Just thinking of alternatives, not considering Lambda as like the only way to horizontally scale things. That's certainly not the case. And not to like hammer on too much about like Fly's great, but like you don't pay for stopped machines. That's freaking cool. You can have all of these up and running, and you have them start. They will start up as quickly as your web server will start up. So however long it takes to run npm run start, that's how long it takes. Or you can have them run different processes as well. But yeah.
Seems like the video still gets uploaded to that main server, and then that video then gets streamed back through to Sexton. You have a bottleneck of all the videos sometimes.
So I think that you would still be able to send it over as binary, like binary encoded data to the runner app. I believe that, 'cause like nothing is getting written to disk. It's all just getting straight sent over. So I think it would just kind of be like hand the baton over to the runner machine. I think that's how it would work. Yeah.
Still, like, you can only scale as much as that single server could handle 10 video streaming.
Right, and that's where you would want to you would want to also like supplement this by having multiple servers in a different, in either the same region or else other regions as well. Yeah, but that's a good point. Yeah, I will say another thing to consider. If you guys have worked with background jobs before, this feels a little background jobby, but it's not quite that. Background jobs tend to rely on they run whenever they've detected a new job in a queue, like in a Redis queue, right? This doesn't have any consideration for that. So while it's good for scaling in terms of like resource usage, you're not going to get the same reliability that you would with something that's tracking what it needs to be doing in a queue. So you may want to also incorporate some kind of queue to make sure that it's not like dropping jobs randomly. You want to make sure that you have that reliability. So.
Correct me if I'm wrong, we're still on Fly.io for the remix site.
Yeah. It's a really cool platform. It's like the third cloud platform I've worked at, I should say. And it's been really interesting seeing different approaches to serving developers and helping them accomplish the goal of deploying apps on the web. I think Fly it's not for everyone. But I think that we give people a lot more control. And what I learned when I first joined is that I was able to understand lower level concepts much quicker because it's like, that's why I say we're closer to infrastructure as a service. That's just like way easier to understand and launch. It feels like you're just deploying something on like render. It's a similar kind of experience. It's like one command, boom. So. How many of you guys have used Fly? Cool. We got some more people to onboard. It's fine. Soon, it's fine.
There are some great sample code for deploying Fly via GitHub Actions. And there were a couple of repos, and I don't know they're maintained anymore, but it was fully open to go and check out the source code. And so you can actually go and see how Remix Austin deploys to Fly. If you go to the Remix Austin website, you'll see our GitHub action config files and stuff.
Yeah. You talking about like having continuous deployment set up?
Here's the point. We also are able to, if you add the deploy or staging label to a PR, it automatically deploys to a separate machine, and somewhat intelligently by, modifying robots.txt so it doesn't accidentally get crawled.
Yeah.
Other fancy stuff. And then on when you close or merge a PR, it automatically kills that remote PR deployment.
Yeah.
So there are some really neat things we can do with that.
Yeah, there's a couple of basically if you want to do continuous deployment, like auto deploy whenever I push to master or main, there's like a very straightforward GitHub workflow that you just copy pasta into your app, done. It works. I think you have to add your like an authentication key to GitHub, but otherwise that's all you do. And we also have just a standalone workflow that also does like review apps. So every, basically creating a vanilla app based on your code for every PR. And also, this is a shout out to one of the people we partner with. Have you guys used Supabase before for Postgres? Yeah, they're really cool. I really like them. They do. Flight offers a Postgres offering, but it's not a managed Postgres. And so if you want managed, Supabase is the way to go. And they just came out with this branching feature where you can like connect it to GitHub, and it will automatically spin up new databases. If you're using Supabase, you'll probably have like a Supabase file and where it's tracking migrations, any changes to the database, seed data, and it'll automatically spin up new databases. So if you pair that with review apps, you've got like an isolated review app with its own database, with its own seed data. Cool.
Yeah, there may be some stuff we would have got to re-explore with remixaustin.com simply because I think that code was written just over a year ago. So I'm sure things have moved forward the last time I touched it.
Yeah. Actually, if you have any questions about like deployment stuff, that's my Roman Empire at Fly. I really want to make like deploying and that sort of like continuous deployment a lot better. It's already pretty good, but it's I want to make it even better.
Still working. Nobody's complaining to me.
Yep.
And I haven't touched it in a year.
Mhm. And none of it's like hidden behind the scenes, really. It's very like exactly what's happening. Yeah, it's just there in the GitHub action. So, yeah.